Welcome, and in this video course we are looking at the CyberOps Associate version 1 course. This course is going to cover the skills and knowledge needed for successfully handling the tasks and duties, responsibilities of an associate level security analyst working at a security operations center. The goal of this video series is to help prepare learners for the Cisco 200-201 certification. That's focusing on understanding the Cisco Cybersecurity Operation Fundamentals course, known as CBROPS. Module 17, Attacking What We Do. Here we're looking at IP services and enterprise services. We're going to be looking at specifically more IP service vulnerabilities and explain how network application vulnerabilities enable network attacks. So, jumping right on in, IP services. Services such as ARP. These are things that are built into IP services that can be exploited. Hosts broadcast ARP requests to obtain information about determining MAC addresses for particular IP addresses. We should understand how ARP functions. So ARP requests, their replies are called gratitude ARP. A threat actor can poison the ARP cache of devices on a local network. So it really is about taking services that are already there and that are legitimate and using them for more nefarious purposes. Again, the goal is to associate the threat actor's MAC address with the IP address of the default gateway in the ARP cache. This will allow the threat actor or the attacker to start doing man in the middle if all of the devices believe that the MAC address of the default gateway is actually the attacker's machine. That allows for that man in the middle to actually start its process. So this entire process is called ARP cache poisoning. And again, essentially we send out an ARP request, we should get ARP replies. We can be spoofing the gratuitous ARP replies to other machines. That way we know that our default gateway MAC address is such and such. We can now spoof that address to our attacker. That way, all of the devices on the network will send traffic through the attacker machine. Another type of an attack is DNS attack. So DNS attacks normally deal with DNS Open Resolver. An Open Resolver is a publicly open DNS server such as Google's 8888 that answers the client queries outside of its administrative domain. DNS Open Resolvers are vulnerable to multiple malicious types of attacks. Common ones are things like DNS cache poisoning, DNS application and reflection attacks, and DNS resource utilization attacks. Essentially, with the poison cache attack, the threat actor sends spoofed, falsified record sources, RRs, information to the DNS resolver to redirect users from a legitimate site to a malicious site. Again, because DNS is what handles domain names, this is pretty common. However, you can have security on these DNS resolvers so that they're not as susceptible. Amplification and reflection we talked about in the previous chapter or the previous module, but it allows a threat actor to send DNS messages to the open resolver using the IP address of a targeted host. Lastly is the DNS utilization attack. This is where the more of a DDoS attack and will consume all available resources to negatively impact the operation of the DNS Open Resolver. I find it funny that they used Google's 8888 because realistically that's not a single server, that's a data farm full of several servers. So likelihood of consuming all of its resources is extremely low, but it's still possible. Another type of DNS attack is called a DNS stealth attack. To hide their identity, threat actors will also use DNS stealth attacks things like a fast flux, double IP flux, or domain generation algorithm. For the fast flux, the threat actor will use this technique to hide their phishing and malware directory or delivery sites. DNS IP addresses are continuously changing within minutes. That way you do not know the actual delivery site. Double IP fluxes are when a threat actor uses this technique to rapidly change the host name to an IP address mapping and also change the authoritative name servers, the NS servers. This basically increases the difficulty of identifying the source of an attack. Basically, it makes it harder for the people that are analyzing the network traffic to see where the attack is actually coming from. Lastly is the domain generation algorithm. This is where the threat actor will use this technique in malware to randomly generate domain names that can be used as reverse points to the command and control server. This basically allows it to randomly generate domain names for its portion of the attack. A third type is called domain shadowing attack. In a domain shadowing attack, the threat actor will gather domain account credentials in order to create multiple subdomains. www.google.com, gmail.google.com, support.google.com. Those are all subdomains of the main domain google.com. Realistically, someone actually getting the account credentials to create subdomains like that on a well-known server may not be realistic, but for lesser known servers, definitely possible. These subdomains will typically point to malicious servers without alerting the actual owner or the parent domain. If I accidentally fatfinger xxx.google.com, it goes nowhere. Google bought it, but currently it's idle. They did it so that no one else can use it. Well, google.xxx is not really so much a subdomain, but it's a domain with a different prefix. Same thing. Wells Fargo, Bank of America. Being able to manipulate the domain, whether it be the subdomain or the domain prefix, for these types of an attack. Wells Fargo versus Wells Fargo is a good example. WE11 instead of well, WELL. Other forms of attacks within DNS are tunneling attacks. DNS is heavily targeted because that's what runs the internet. So you'll notice that a lot of common attacks focus on key services. IP, DNS, DHCP, because these are services that have to be there for manageability of the network. DNS tunneling basically is the ability to steal data and prevent and contain attacks. To accomplish this, an analyst must implement solutions that can block outbound communication from infected hosts. Basically, the threat actor will use DNS tunneling, place a non-DNS traffic within DNS traffic. Basically, you'll hide traffic and mask it as DNS traffic. This method is often circumvents security solutions because DNS traffic might be legitimate. So doing something like deep packet inspection may slow the network, but it verifies inbound and outbound packet types. For the threat actor to use DNS tunneling, different types of DNS records such as a text record, an MX record, a service record, a null, A-frame, a quad A or CNAME would be altered. One of the big examples is using a text record that can store commands that are sent back to the infected host as DNS replies. You can embed commands inside text records, inside DNS. So understanding where you're getting your DNS from is actually extremely crucial. So to stop DNS tunneling, basically you filter and inspect DNS traffic. Deep packet inspection, looking at that DNS traffic, is pretty common. Next is DHCP. You guys should be familiar with the DORA. Discover, Offer, Request, Acknowledgement. DORA. Well, this is the normal process for DHCP. Well, DHCP dynamically provides addresses. DHCP works off of broadcasts and unicasts, but the server will respond with a unicast address when broadcasts are sent to it. So we have to be careful here because these broadcasts can be erroneously generated to cause the server to start offering addresses and can actually cause what's called DHCP starvation. That's where the scope of the DHCP address pool is basically not large enough to serve all of its hosts. If an attacker is able to siphon off, 200 hosts, if the pool was only 200 addresses, there aren't any addresses to actually hand out. Another common type is DHCP spoofing attack. This is where your spoofing occurs when a rogue DHCP server is connected to the network and it sends out false address information to legitimate clients. It provides the wrong gateway, the wrong DNS, the wrong IP addresses. While this could be by accident, I've spun up DNS servers on a network and I was configuring it based off the network documentation that I had, and it turned out it was the wrong information, so I black holed a bunch of traffic. So legitimate attacks, legitimate issues with DHCP like that can occur. However, when it's malicious, when it's on purpose, there's spoofing attacks. So we have a lab looking at capturing DNS traffic and exploring the query and response. Moving on, we have our enterprise services. So we talked about IP services, the core features of IP and how they can be exploited. Now we can look at some of the enterprise services, things like HTTP and HTTPS. HTTP and HTTPS are used for web content. Common stages of a typical web attack: basically the victim unknowingly visits a website, typically compromised by malware. The compromised web page redirects the user to a site containing additional malicious code. The user will visit the malicious site with malicious code, and their computer becomes infected. After identifying a vulnerable software package running on the victim's computer, an exploit kit can contact the exploit kit server and download additional malicious code. So, for example, let's say you visit site x.com. If x.com is malicious, it can download malicious code on your site. It will look at all the applications you have, and if it finds a malicious, if the malicious code finds an application that is susceptible or vulnerable to a type of an attack that it knows about, it could then compromise that application. It can then exploit that vulnerability by downloading additional malicious code. So the victim's computer keeps downloading additional and new malicious content. Finally, the malware package is ran on the victim's computer based off of the application that was originally infected. The application just acts as a door. Once the door is open, malware can be downloaded and installed. Common HTTP and HTTPS connection statuses are: anything with 1 is informational, anything with 2 is successful, anything with 3 is redirectional, anything with 4 is a client error. All of these will be based off of the standard HTTP request connection codes. A common way to block web-based attacks are using things like proxies or filtering web content. Filters are becoming more and more commonplace. That way, malicious sites cannot be redirecting legitimate users to those sites. User training in this area is huge because being able to spot malicious web content is extremely important. Sad fact is, a phishing email with a malicious link can cause havoc on a network. Other forms of HTTP exploits could be like malicious iframes. Again, an iframe is an HTML element that allows the browser to load another web page from another source. So you may have the main web page, but you could have sections of that web page that load additional content. Maybe the left side or the right side that load other content from other locations. Well, those are called iframes. Those iframes can actually load malicious content. So to prevent or reduce malicious iframes, again, web proxy, you can also ensure that your web content doesn't use iframes, or you can use some type of blocker, web content blocker, that will actually prevent malicious code from loading. Cisco has the Cisco umbrella. However, there's tons of web filtering software out there that's pretty common that organizations are implementing to prevent these types of attacks. We have an HTTP 302 cushioning. This is where a threat actor will use the 302 error found in the appropriate HTTP response status code to direct the user's web browser to a new location. Again, proxying or web filtering will prevent these types of attacks. This is definitely one of those attacks that are still occurring occasionally, but most modern day browsers and security features prevent these types of attacks. Domain shadowing is another type of a common attack. This is where a threat actor creates a domain shadowing. First, they compromise the domain, then they create multiple subdomains, and then they use these subdomains to hijack a domain registration login. Basically, they hijack a login, they create a bunch of subdomains, and they use the legitimacy of the main domain to push this content. Because if you trust google.com, you may trust support.google.com. What I mean by that is you may trust the main domain, so you have that inherent trust to trust all subdomains because of that. So how do you prevent these types of attacks? First of all, ensure that the login credentials for the domain account are secure. Set up web proxies using web filtering, and ensure the owner detail validation is required. If I go to log into my domain software or my domain account for any of my web domains that I own, I have to do two-factor. Email, password, and I get a text message that delivers a code. That way, realistically, the additional layers make it a little bit harder. Not impossible, but harder. So we talked about HTTP and HTTPS based attacks. Now we have to talk about one of the main sources of attacks, email. All the levels of organizations, whether big, small, huge, government, doesn't matter. Security while dealing with email is only becoming more important. The way users access their email is also becoming an opportunity for threat actors to introduce malware. Examples of common email threats: attachments, spoofing, spam, open relay. An attachment-based attack will be someone sends you an attachment, you open the attachment, you get infected. Very, very, very common is, I sent you an invoice. Here's the see the attached invoice, and it shows as a PDF. In reality, it's malicious content. Or, hey, I'm sending you a Word document for you to review. Review this memo, and they attach a Word document. Well, again, it's malicious content. If you don't know who's sending it, don't open it. Email spoofing is also very common right now. That's where you're forging, sending information. I get tons of email from Amazon saying that my package wasn't delivered. Except when I mouse over the actual email address, it shows that Amazon didn't send it. Someone at domain gyxcz5.org did. Even though the initial name said Amazon, it doesn't always necessarily mean it's really coming from that account. Again, those are spoofed. Spam email, that's where the threat actor will send unsolicited emails, advertisements, or other malicious files to your email. I get probably 1,000 pieces of spam for one of my email accounts every day. And so I actually had to deploy a spam filter to ignore 90% of my email to that email account. Spam is becoming ridiculous, but it does still happen. Open mail relay servers, basically anyone on the network or the internet can send mail through your mail server. If it is not secured properly, that's acting as a relay. You can also do voice relay, where you have a voice over IP server, and you can make phone calls through someone else's PBX if it's not secured properly. All of these have best practices for implementation. That is how you prevent them, by actually looking through the best practices and following the appropriate guidelines. Other forms of web exploits are going to be databases, code injections, SQL injections. Anything that deals with a database on the back end can be exploited. You go to Amazon and you go to the login. Well, that login is stored in a database. You can inject content there. If you can manipulate the quantity, for example, if you can type it in, you can inject code. How do you prevent this? Well, it's really simple. You can do browser or server-side integrity checking. Maybe in the login, you only allow login. You don't allow code execution. In the quantity boxes, maybe you only allow numbers. You don't allow code. So actual text box validation plays a huge role. Honestly, all of that goes back to best practices for web coding. Other forms of client enterprise services are going to be things like web cross-site scripting. And this is where a web page that's executed on the client side within their own browser is injected malicious code. Typically, like Visual Basic or JavaScript is going to be there to inject code. Two types of XSS. XSS is cross-site scripting, stored or reflected, non-persistent. What happens if I upload a JPEG for my photo as an avatar? Well, every time that photo is viewed, I could actually have code built in to run exploits. And the end user wouldn't even know. How do we prevent this? Well, first of all, we follow the web application developers are aware of the vulnerabilities that XSS exists. We use the appropriate IDS and IPS implementation to detect and prevent the scripts. We can do web proxies to block malicious content. We can also do basic web filtering to filter out these types of sites. Also, we can ensure that the sites we are going to are coded appropriately following the common OWASP exploits so that they are prevented. We've already talked about attacking a SQL database, so we actually are going to be having a lab where we do this. We have a lab where we are looking at server logs, and that is the end of this lecture. So we talked about ARP, we talked about DNS, we talked about DHCP, we talked about key IP services. We talked about common web exploits, HTTP, HTTPS, databases, and a little bit about OWASP. Again, OWASP top 10 are going to be the main web application security risks that are the most vulnerable and most known. That is it. Any questions or concerns, please feel free to reach out and let me know. Thank you.